Okay, so you're telling me there are no questions? You understood everything. That's impressive. Everything about life too. So we talked about how to complete the square. You know how to solve these by completing the square graph thing using completing the square. And we also talked about how you can use that formula negative b over 2a and all that sort of stuff. You know, the quadratic formula, how to solve things using the quadratic formula. Jeff?
On the homework, are there any ones on that very complicated method? I think it was example 3. You said that was the hardest one out of.
Like this one right here that had the little fractions and stuff like that?
Homework that are like that?
I think there's one. Okay. Okay. So when we left off yesterday, I said you could get started on page 295, and then we were going to look at the rest of these problems. In order to solve these other problems, you have to know how to work with quadratics. You need to know how to solve those. You need to know how to graph them and stuff like that. But hopefully we'll look at this in just a little bit different way. Before we can solve them, you've got to come up with an equation. So let's take a look at this example right here. It's got farmer. It's got 2,000 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? Okay, so he's going to go out and enclose the field in a rectangle, looks something like that. He's going to use 2,000 yards of fencing in order to make that happen. And he wants to make the largest area possible. Because what he could do if he didn't like his animals very much is he could do 1 yard here, go way out here, 1 yard here, and like that. So then the animals can just kind of go back and forth like this. Wouldn't be very nice and wouldn't be very much area because this would be 1 yard here and 1 yard here. What is it?
Oh, I know, 1,000.
Okay, so we would have used 2 yards out of the 2,000 yards. That would leave 1,998 yards. So this would be 999 here and 999 there. That's 2,000 yards altogether, right? Or another way to think of it is if, see this side right here and this side right here, they're half of the perimeter of the rectangle, so they have to add up to half of whatever the fencing is going to be. So another thing that we could do is we could do something like this. This would be kind of cruel. Let's say this was 10. What would this side over here be? 990. The easy way to figure it out is take half of this. That's going to be these two sides added together. So if this is 10, that's got to be whatever's left of 1,000. So that's going to be 990. Okay, not very wide, really tall. Not a very efficient way to enclose space. Okay, but maybe that is the biggest. Probably not that. This one's definitely more area than that one right there. So what we want to do is we want to come up with a function that represents the area of that rectangle. It doesn't say that, but we've got to figure that out in order to figure out what are the dimensions of the rectangle that encloses the most area. Okay? So there are a couple different ways that we can do this. Let's first approach it the way we talked about in the last section of chapter 3. If this is x and I've got a rectangle, I know what one of the other dimensions is. I know that's got to be x. I don't know what this dimension is here, so guess what variable we're going to use here? We're going to use a y. And then I want to know what the area of that rectangle is. X times y. Amber, what don't we like about this? It has two variables. So then we've got to stop and think about this, and we've got to come up with some way to get rid of that y. We've got to come up with some way to write it as a function of x. Any ideas? Well, there's a piece of information in the problem that we haven't used yet. The 2,000 yards. So ignore this area thing over here. Let's just focus on this picture right here. And let's think about what we know. We know that the fencing can only add up to 2,000 yards. So I've got 2,000 yards of fencing. And I'm going to use it around here, 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 and here. So if I haven't used that piece of information, I could probably use that now and try and use it to get rid of the y. So any ideas? Got 18 people in here. Ought to be able to put our heads together and come up with an answer. John?
Could you multiply the sides, like, maybe like 2x and 2y, and then since there's 2,000, then you make it equal that?
Okay, so not multiply, we're going to add. Because what he said was 2x and 2y, because I have 2x's and 2y's. Or in other words, if I just went through and added up the perimeter, perimeter is what you get when you add up all the side lengths, right? This would be 2x plus 2y equals 2,000. And could I solve that for what y equals? Sure I could. Okay. One thing I could do is I could go through and divide everything by 2, in which case I get x plus y equals 1,000. And if I want to know what y is, move the x to the other side. So this would mean y equals 1,000 minus x. Any questions there? So the area as a function of x is x times 1,000 minus x. Now before we leave that, because right now we're going to be able to solve the equation, we're going to get the answer to this one. I want to come back here and I want you to think about the two that we had up here earlier. This one was 1. What's this one right here? 999. When I said this one was 10, about half of you said, well, this other one's got to be 990. How did you come up with that answer? 1,000 minus 10. So if this one is x, how could I represent that one right there? I could do 1,000 minus x, okay? Because I know between the two of them, if I kind of cut this in half, x plus y has got to equal 1,000. So if I've got x here, this has got to be whatever's left of 1,000. So I just do 1,000 minus x, okay? Nothing wrong with doing it this way and solving here. Nothing wrong with doing it that way and plugging it in. We get to this point either way. Okay? Any questions? Okay. Now I want you to watch. This is the way I'd like you to do these. If I were to multiply this together, I'd get 1,000x minus x squared. If I were to graph that, what shape is it? What is it, Walker? It's parabola. Which way does it open? Down. Why does it open down? Why does it open down? Because the negative in front of the x squared. Whatever the sign is in front of the x squared, that'll tell you whether it opens up or down. If it's positive, it opens up. If it's negative, it opens down. Okay, next question. What will make this factor right here equal to 0? 1,000. If I plug in 1,000, that whole thing would equal 0, right? That means it's an x-intercept. What would make x equal to 0? What would make this factor equal to 0? It'd be 0, wouldn't it? Okay, for some reason that trips people up. Okay, what would make this one equal to 0 is 1,000. What makes this one equal to 0 is 0. Okay? Those are the x-intercepts. It crosses at 0 and it crosses at 1,000. Now let's stop and think about this for just a second. Walker, you said this is a parabola that opens down, right? We talked a whole bunch yesterday about the axis of symmetry. So if I make a parabola that opens down, it's going to look something like this, right? And didn't we say yesterday that the x-intercepts are equally spaced on either side of the axis of symmetry? In fact, if we slide up here, see this picture right here? We had the axis of symmetry right here, and on this particular one, we went over 3/4 and we went back 3/4. So if we look at this diagram right here, if this crosses the x-axis at 0 and at 1,000, where's the axis of symmetry? At 500. And if that's the axis of symmetry, that's also the x-coordinate of the vertex. So what should x be to have the maximum area? $500. What should x be to make it the maximum area? It should be 500. So if this is 500, what's this over here? Also 500. 1,000 minus 500 would be 500. Okay? So it says, what are the dimensions that enclose the most area? We would say 500 by 500. 500 in width and 500 in length.
But wouldn't that be a square?
So Corby says, wouldn't that be a square? Is that a square? Yes, it is. A square is a very efficient shape. Is a square a rectangle? Yes, it is. So every square is a rectangle. Is every rectangle a square? Nope. Okay. A square is just a very special type of rectangle. Okay. Any questions? Yeah.
So why is the other one 500?
Because remember this formula that said if you know x, you can plug it in here and you can figure out what y is. So if we figured out x is 500, y is going to be 1,000 minus 500, which is going to be 500.
And you find out x by the axis of symmetry?
You find out x by the axis of symmetry. Because this is the x-axis and it literally represents how wide the rectangle is. And then remember this is a of x, this is the area. So the area is 0, then it gets bigger and bigger and bigger. It reaches a maximum area right here at the vertex, and then it goes down. Okay. So this would be that silly example that I gave before. If x is 10, we don't have much area. And if we made a really wide width, we hardly have any area. Really small areas, they get bigger and bigger and bigger areas. The biggest area is right here when x is 500, when it's a square. Okay. And then the minute we start to make this wider like this, it gets smaller and smaller and smaller as far as the area goes. Any questions? Okay. Don't write this down, I just want you to watch. I'm going to take this one right here, and I'm going to write it like this. Negative x squared plus 1000x plus 0. And I'm going to figure out where the vertex is. A in this problem would be negative 1, B in this problem would be 1000, and C in this problem would be 0. If you plug that into the quadratic formula, you'll get the two intercepts of 0 and 1000. If all we're interested in is where the maximum occurs, we want to know where the vertex is. So what was that little formula? Negative b, negative 1000 over 2a. So that's going to be negative 1000 over negative 2. Negative divided by negative is positive. 1000 divided by 2 is 500. Okay? Plug that into the formula and it'll tell you what the maximum area is. Okay? We didn't figure out what the maximum area was in either case because it didn't ask for it. What it asked for, what are the dimensions? So the farmer just wants to know, okay, I'm going to go out and I'm going to make this fence and then this fence and this fence and this fence. Tell me how long I need to make each one of them. Okay? Now, if we wanted to figure out what the maximum area is, plug in 500 here, or let's look at this. If that's 500 and that's 500, 5 times 5 is 25. How many zeros do I need altogether? Say 4. It's 4. I realize it's Friday afternoon and everything. So 250,000 square yards. 250,000 square yards. That's gigantic. Okay? Any questions? Does anybody know roughly how long that is in miles? It is, very good. How many feet in a mile? 5,280. If this is 3 feet in a yard, this is 6,000 feet of fence. Okay, so this is a ton of fencing. Okay, any questions? Okay, flip the page over. This next problem is different. Squares are very efficient shapes. If you're going to enclose something, the most efficient way to maximize the area is to make it into a square. But if we alter the problem just slightly, which is usually more of a real life situation, then we end up with a different type of answer. So now the problem is changed to this. The farmer's now going to use 2,000 yards of fence to enclose a rectangular field, but one of the sides will border a river. So we won't need to fence that side. What are the dimensions of the rectangle that encloses the most area? So here's what we've got. Got a little river on this side. And that's what we're going to fence in. So we don't have 4 sides to fence in. We only have 3 sides to fence in. Now, a lot of times, I mean, we just kind of go for the most convenient thing, like make this one, don't write this down, make that x. Here's what makes this a little bit more difficult. If x is what you like to use, choose the diagram or the part of the diagram for x that you're going to be able to label the most of. And what I mean by that is, what if I put an x here? What else do I know is x on this? The other side over here. If I put the x here, that's the only one that I know, and then I'm going to have 2 different y's. That would make the problem a little bit more difficult. Okay? So by choosing x to go here, I automatically know 1 more piece of my diagram. Okay? If there were another fence in here, I'd know 3 pieces of the diagram. You with me? What am I going to use for this? We'll use a y for that. I'm interested in maximizing the area. So look at this rectangle. The area is y times x. Amber? We don't like those 2 variables. We want to get rid of one of these. So stop and think about what we did on the last problem and see if you can figure out. We haven't used a piece of information that's in the problem. How could we use that piece of information to figure out a relationship with x and y, an equation with x and y, so I can get rid of that y that I don't like there? Josh? Sure. Okay, so Josh says it's 2x plus y equals 2,000. And what did you do there? How did you get that? No, how did you get that? Yep, the 2 x's and the y, that makes up the fence. It's the same thing that we did up above, but instead of having 4 sides to worry about, x plus y plus x plus y, we only have x plus y plus x to worry about. So there's our equation. And what variable do we want to solve this for? We want to solve it for y. So I'm going to move that to the other side. So it's going to be 2,000 minus 2x. Now, take a little bit of thought right here. Think about what this is saying. Just like up above where we had 1,000 minus x, look, if the 2 of these together make 1,000, if I know what x is, then y's got to be whatever's left of 1,000, 1,000 minus x. What we're saying on this problem right here is, if I know what x is, I've used 2 of those. So whatever I've got for y is going to be what's left of the 2,000 once I take out the 2x. 2,000 minus 2x. Any questions? Yeah.
Why don't you do the same thing as you did on the other one and divide it?
What do you mean?
So on the first one we did, you divided it all by 2.
Because it's the short answer is it's not symmetric. We don't have this other piece up here to worry about. So we wouldn't just divide the 2 of those and say that's going to be 1,000. Because that would leave a ton of fencing just to use this one. It would equal the 2 of those added together. Good question. Okay, so let's go ahead and write this as a function of x. This is going to be 2,000 minus 2x times x. If I were to graph this, what shape is it? It's a parabola, right? You can tell it's a parabola by distributing through. That would be 2,000x minus 2x squared. Walker, which way does this open?
Opens down.
It opens down. Okay? He's thrilled about that. Okay? What makes that factor equal to 0 and what makes this factor equal to 0? 0 here. What would, yeah. Let's see, minus 2x is equal to 0. So if I move that to the other side, 2,000 equals 2x. So that's going to be x equals 1,000. Those are the 2x-intercepts. What would I plug into this to make that whole thing equal 0? If I plug in 1,000, I get 2,000 minus 2,000. So this is what it looks like. This is 0. And this is 1,000. It opens down, it looks like this. If this is 0 and that's 1,000, where is the vertex? It's at 500. Okay, now here's the interesting part about this. The answer in both cases is 500, but that represents this side now. That's 500, and that's 500. Oops. What's this one? That one's got to be 1,000. Okay, so is it the same shape as it was before? It's not. Not the same shape as it was before. Okay, it says, what are the dimensions? So the dimensions would be 1,000 yards by 500 yards. And just for the heck of it, if I multiply those together, I get a 5 followed by how many zeros?
A lot.
Wait, is that the axis line or the
What are you talking about?
that line you're just?
This right here? Yeah, that's the axis of symmetry. Okay, here's the y-axis or the area axis. Here's the x-axis. So 500,000 square yards this time. How many was it last time? 250,000. So by not having to enclose that one side, we get to double the area with the same amount of fencing. Eliminate that one side, double the area. Okay, any questions? Okay, we're going to do one more problem and then we'll be done. The reason we need to go over these problems is these are very often on the final exam in 1050. Okay, so we're going to see these probably 2 or 3 times throughout the semester. So it would be really good to get used to them now and understand the vocabulary and stuff like that, so that when you see something like this on the final exam, it's not confusing. Okay, so the first question is this, just to kind of get us thinking in the right direction. If I sold 4 items for $5 each, how much would be generated? $20. Oops, $20. What if I sold X items for $5 a piece? 5X. Okay, 5X dollars. If I multiply these two together, how many I sold times how much they cost to get $20. How many I sold times how much they cost, I get 5X dollars. So this is a variable expression, and the nice thing about variable expressions, even though they've got letters in them and we're in a math class, is I could tell you any number that we sold on any particular day, and you would quickly be able to figure out, well, how much money did we generate? So if I said I sold 100, 500. If I said I sold 2, $10. Okay? So that's the value of a variable expression like that. So if I sold 8 items for $7 each, how much money would be generated? 56. So what if I sold 8 items for P dollars each? That's going to be 8P. Now you'll notice that the variable is different for each one of these. Okay, on this one, I didn't know how many I sold, but I did know the price. On this one, I don't know the price, but I do know how many I sold. So here, the number that I sell is changing, that's the variable, and here, the price I sell it for changes. So if I sold 8 items for $6, 48. If I sold them for $2, 16. Okay? So I've got a variable expression that will tell me how much money I generated if they're $5 a piece. You tell me how many I sold. And I've got a variable expression that represents how much money I generated if I sell them for this much. You tell me what the price is. Okay? All right. So what if I sold X items for P dollars each? How would I represent how much money's generated? What is it, Bree? It's X times P. So it's the number that I sell times the price that I sell them for. That represents how much money I generated by selling X items if they're priced at P dollars each. Okay? Does anybody know what we call the money that we generate from a sale? Gross income is one way to put it. A lot of times we'll use one word, we call it revenue. Okay? Is revenue the same as profit?
Oh.
Is revenue the same as profit? Revenue is not the same as profit. Okay? What if I sold something for $100 and it only cost me $90 to make it or get it? Did I have profit? $10 profit. What if I sold something for $1,000 but it cost me $1,200 to buy it or make it? I just lost money. Okay? Not a very smart business model. Okay? So revenue is only how much you generate. It's just how much money comes in. It doesn't have anything to do with profit until we know what the cost was. Okay? So the formula for revenue is this. It is simply X times P. We just take how many we sell times the price. So how many you sell times the price for each one of them. Okay? Now, some of you may have taken like a personal finance class or maybe an economics class or something like that, and you've learned about supply and demand. Okay? If the supply goes up, usually the price goes down. And if the demand goes up, usually the price goes up because people are willing to pay more for it, so you'll raise your price and stuff like that. So the way we could talk about this is called a demand equation. Okay, we could also call it a price equation. And it says express the revenue as a function of X. Express the revenue as a function of X. Now, that can be kind of a tough question, but take a look right here. What does R represent? R represents revenue. So the revenue is equal to X times P. Amber, we don't like the two variables. Which one do we like better, X or P in this particular case? We like X, because it says write it as a function of X. So which one do we want to get rid of? We want to get rid of P. Well, guess how we're going to get rid of P? Right there. So let's take that and let's solve that for P. First thing I'd do is I would subtract 100. So this is going to be X minus 100 equals negative 5P. Then I'm going to divide both sides by negative 5. So this is what I get. I'm going to write this as negative 1/5 X plus 20, and I'm going to say that's the same as P. So take a good look at what I did here. I broke this into two separate fractions, X over negative 1/5 and negative 100. Sorry, X over negative 5 and negative 100 over negative 5. So I'm going to pull that 1 out front. It's like a negative 1/5, so I can see what the coefficient is, and then plus 20. And that's what P is. So if I write revenue as a function of X, it's going to be X times what? Negative 1/5 X plus 20. Okay? That's the answer to the first part. So there's the answer to part A. And usually that's the hardest part. Not always, but usually that's the hardest part. Once you get to there, you can figure out most of the problems. Okay, before we go any further, let me just kind of sum up. This is the demand equation. I've got a circle around it. This is the revenue equation. I've got a circle around it. If I had to give a name to this right here, since it says P equals this stuff right here, what does P stand for again? Price. That's kind of the price equation right here. The demand equation and the price equation are related. Here it's solved for X, what the demand is going to be, how many we want to sell. Okay, and over here it's solved for P, what's the price going to be set at. Okay. I think everything from here on out, if you get those things, shouldn't be too terribly bad. You in good shape? Okay, let's look at part B. What is the revenue if 15 units are sold? How much revenue is generated if 15 units are sold? What are we going to do? Plug in a 15. So I'm going to take R of 15. So that's going to be 15, negative 1/5 times 15 plus 20. And what is 1/5 times? Very good, thank you very much. That's negative 3 plus 20. So that's going to be 15 times 17. So that's going to be $255. Is that right? Part A here, part B here. Ready? Any questions about this one right here? Okay. What quantity X maximizes the revenue? So when do we have the maximum revenue? How many do we sell to get the maximum revenue? And what is the maximum revenue? We want to find the maximum of the revenue. This entire section is on quadratics. Quadratics are parabolas. Take a good look at this. Does this parabola open up or does it open down? This would be negative 1/5 x squared and then plus 20x, right? Opens down. What's the x-intercept that comes from that factor right there? What makes that equal to 0? 0. What makes this equal to 0? This is a little bit tougher question. Opposite of that number, so negative 20, divided by that number right there, so that's going to be negative 1/5. Do we ever divide by a fraction? What do we do, Tanner? Multiply by the reciprocal. So I'm going to take that and I'm going to flip it over and I'm going to multiply by negative 5 over 1. What's a negative times a negative? A positive. And 5 times 20? 100. Okay, so what would make this one equal to 0? 100, and that would be 0. So it crosses at 0 and crosses at 100. And Walker, we said this is a parabola that opens. Why down? Because of the negative in front. So it looks something like this. Okay. This is the x-axis. That's how many items we're going to sell. What axis is this? It's not a y-axis anymore. What is it, Alex? Price, or in this case, revenue. Okay, so that's the revenue axis. That's how many dollars we bring in. Just take a look at this. How many do we have to sell to have the most revenue? 50. Okay, X has got to be 50. So if I plug in a 50, what do I get? Well, let's take a look. If I plug in a 50 in here, so if I want to figure out what R of 50 is, that's going to be 50 and then negative 1/5 times 50 plus 20. Just like we did for R of 15, how much money did we generate when we plugged in 15? We got $255. This is going to be, what's negative 1/5 times 50? Negative 10. So this is negative 10 plus 20. So this is 50 here and 10 there. What's 50 times 10? 500. And that's in dollars. So if you sell 50 of these items, you're going to bring in $500 in revenue. So what quantity X maximizes the revenue? 50. What is the maximum revenue? $500. Okay, now let's pause right there for just a second. Are there any questions? We've gone through parts A, B, and C. Found the revenue function. Plugged in 15, found that if we sold 15 of them, we're going to make $255 in revenue. We figured out that this is a parabola that opens down. It crosses at 0 and 100, so that means the vertex would be at 50. 50 items is where I produce the most revenue. And I plugged in 50 and I figured out if I sell 50 of them, I bring in $500. So there's my revenue. Okay? Any questions about that? Okay, then we'll take a minute and look at the last question. And I'm going to say you have everything you need on this page, and it's been pointed out to you. Because the last question is, what price should the company charge to maximize the revenue? They know they need to sell 50 of them, but how do we set the price so that we can sell 50 of them? Set it too high, 50 people aren't going to come in and buy it. Set it too low, more than 50 will come in and buy it, but they're going to buy it at a lower price, so we're not going to bring in as much money. So we want to kind of balance that. We want to bring the right 50 people in that will pay that exact price so we can get the most money for this. Who knows what we need to use in order to figure out what price we're going to charge to sell 50 of them? I've got half a hand from Sherwood. Anybody else? Tori, maybe? Tanner, maybe? Tori, what do you think? What do we do?
This is just a guess, but would you plug 50 into the negative 1/5 for x?
Awesome. Okay, so we're going to plug it in right here. That's the price equation, isn't it?
Yes.
What happens if you plug in a 50? You get 50 times negative 1/5, which is negative 10, plus 20. That's going to be positive 10. Isn't it that number right there? Okay. And didn't we say it was the number times the price? Well, we knew we sold 50. That number right there is the price. X times P. Whoops. There's the P. So the price is 10. So if you set the price at $10, we'll get 50 people in here and we'll maximize our revenue. If you set it at $11, watch what happens. If we set it at $11, more people come in, but they pay less for it. Set it at $11. Here's what would happen. If you set it at $11, fewer people would come in and they'd pay more for it, but we wouldn't raise as much money. Okay. Set the price too low, tons of people come in and buy it, but they pay less for it. Okay? So that's kind of a nice balance there. Any questions? Okay. Don't be surprised if you see something like this on the next test, and don't be surprised if next semester when you're taking 1050, which is when you should take 1050, if you see something like that on the final exam. Okay? It's been on there about half the time. Okay? All right. No questions?